We want to look at hyperbolas, which have two branches. If you remember, if you had that cone and the plane intersected the cone, there were certain ways the plane could go through and intersect twice, and so you'd have two branches. It looks like two different parabolas, but this is a hyperbola. It's similar to an ellipse in definition, but remember, ellipse was the sum of all distances between the foci and some point, and hyperbola is the difference of the distances. So if we want a definition for a hyperbola, which is not to be confused with hyperbole, but a hyperbola is the set of all points x, y in a plane the set of all points x, y in a plane the difference of whose distances from two fixed points called a foci is a constant. So by definition, somebody would ask how did the foci come into it? It's part of the definition. The hyperbola, if you find a point on the hyperbola, say we have this point xy, the difference of the distances between these 2 points, that's D1 and D2, the difference is anywhere on there is a constant. All right, now looking at our hyperbola, our vertices are here, just probably where you would expect them to be, looks like where the vertice of a parabola would be. We have 2 vertices. We have a center point. Let's make that, our center point is right here. And we have the distance between the vertices, or the chord that joins the vertices. Let me change colors. The chord that joins the vertices is called the transverse axis. And you could have a vertical transverse axis, or you could have a horizontal transverse axis. But the distance between, or the chord that joins the vertices is called the transverse axis. Just like with an ellipse, the distance from the center to the vertex is A. And the distance from the center to the foci is C, just like it was with an ellipse. The distance from the center to one focus, or both of them actually, to the foci is C. So the distance between foci is 2C. The distance between vertices is 2A, just like it was with an ellipse. The difference being that C is going to be bigger this time than A, because C's inside the branches of the hyperbola. We'll use B, but B helps us to find the asymptotes when we go to graph the hyperbola. So let's look at the 2 forms of the equation for the hyperbola. You have a question, Charlie? Is C. Sorry, I probably didn't get it written. I was talking. Okay, it's C. Just like it was with the ellipse. From the center to the focus is C. From the center to the vertex is C. So the center always lies between the vertices, halfway between the vertices.
Right, so the center is what's halfway between the vertices and the 2 parabolas.
Yes. Well, they're just different branches of the hyperbola. They look to us like parabolas, but a parabola just has that one branch. Okay, 2 forms of the equation. Yes.
Where is the vertex on?
the vertex, there's two of them. Here and here, two vertices.
And the foci lie in.
Inside each branch. Just like it did with the parabola.
Right.
The focus was inside. All right, so if we have a horizontal transverse axis, okay, we have a horizontal transverse axis. That means it might look something like this. Our formula is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, and we'll say the center is hk. Center's always hk, except for a parabola where that's the vertex. Okay, this is a horizontal transverse axis. For a vertical transverse axis, let me just say this too. We'll go ahead and give you the equation for the asymptotes. The asymptotes here, which are helpful in graphing the hyperbola, helps us to know how wide or how narrow each branch is. The asymptote here is going to be k plus or minus b over a times x minus h. That's the asymptote that's useful in helping us graph a hyperbola. We'll see that in a few minutes. But that's the equation, and I'll give you the equation. I'm not going to ask you to remember it. But notice slope is change in y over change in x, so we want whatever's under y over whatever's under x. Yes, ma'am?
So is that standard form? Or what is
That's standard form for a hyperbola. All right, if we have a vertical, let me see if I can move that out of the way. A vertical transverse axis. That's like the one I just drew before when we first started talking about them. Again, the center is HK. This time we're going to have y minus k squared over a squared minus x minus h squared over b squared equals 1. A squared always goes first. Didn't matter on the ellipse, it could be first or second, but here it's always first, and it's based on whether you have a horizontal transverse axis or a vertical transverse axis. This time our asymptotes, it's still y equals k, but it's plus or minus a over b times x minus h. Notice whatever's under y over whatever's under x. Change in y over change in x. If you didn't have the formula there, it's change in y over change in x, so you can remember whatever's under y over whatever's under x. Our formula for c squared this time is c squared is equal to a squared plus b squared. So I want to find the standard form of the hyperbola whose foci are -1, 2, and 5, 2. And its vertices are 0, 2, and 4, 2. So I always like to just sketch it so I know what I'm looking at. So here's one focus point. Here's a vertex. Let's do that one in pink. Our other vertice, let's see, that's a vertex. 1, 2, 3, 4. Here's another vertex. And then the focus is right here. So that means it's going to go this way, something like this. We can hone that a little bit more in a minute. Okay, so do we have a vertical axis or a horizontal axis?
horizontal?
Horizontal axis. So what's going to go first, the x or the y?
X.
The x is going to go first. So we've got to figure out what is the center. Just like we did with an ellipse. If we know what the vertices are, can we find the center? Okay, it's halfway between. So if the vertices are 0, 2, and 4, 2, 4 minus 0 is 2. So our center is the point 2, 2. It's also halfway between the foci. All right, so there's our center. If we want to figure out what A is, we know that A is the distance between the center and a vertex. So can you tell me what A is?
Yeah,
A is 2.
Right here it says.
To the foci is 3. So if we just want to find B, we know that C squared equals A squared plus B squared. So we have 9 equals 4 plus B squared. So what is B squared?
How did you know it was 2?
How did we know A was 2?
You have, use it corrected?
It's the distance from the center to the vertex, or take half the distance between the vertices. The distance between the vertices is 4, so half of that's 2.
And then how did you know C was 3?
That's the distance between the foci, from the center to the focus.
I see that. Always center to the foot.
Center to the focus. Okay, so B squared is 5, so B would be the square root of 5. Okay, so let's see if we can come up with an equation now.
y minus 2 squared over 4 minus y minus 2 squared over 5.
Y minus 2?
X minus 2 squared over 4.
X minus 2 squared over 4.
Minus y minus 2 squared over 5.
Y minus 2 squared over 5 equals 1. Good. Now, if I wanted to graph the asymptote, we can always graph it. The equation for the asymptote would be y equals 2 plus or minus, square root of 5 over 2 times x minus 2. Okay. Now, if I want to graph that, we always can graph the asymptote from the center. Square root of 5 is just a little bit more than 2, right? So if I go up to, okay, we have foci of 0, 0, and 8, 0. And vertices of 3, 0, and 5, 0. I want to find the standard form of the equation, and we'll go ahead and find the equation for the asymptotes and graph it. So let's see what we're looking at. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 0. And the vertices are 3, 0, and 5, 0. Okay, so there's my vertices, my foci are graphed. Is this horizontal axis or vertical axis?
Horizontal.
Horizontal, so x is going to be first. It's going to be x minus something first.
The center is going to be
It's going this way, horizontal. So what's the center, Charlie?
4, 0.
How'd you get that?
You go halfway in between the vertices.
Halfway between the vertices. The distance between them is 2, so half of that is 1, so the center is 4, 0. In other words, A is 1.
Right.
So here's our center. Can we figure out what C is? What is C? Not 8.
A is 1, C is
4, half that distance. So we know C squared equals A squared plus B squared. 16 equals 1 plus B squared, so what's B squared? Square root of 15. I mean, b squared is 15, sorry, but b is square root of 15. So b squared is 15, and b is square root of 15, which is almost 4, not quite 4, almost 4. Okay, so let's see. In our equation, we said it's going to be x minus what?
4
4 squared over a squared
which is still 1,
minus,
minus y squared, because there's no y value.
okay.
Yeah.
Yes, ma'am. She's taking her semester exam. She's taking her semester exam. Okay, so there is our equation. If we want an equation for the asymptotes, it's y equals 0 plus or minus square root of 15 over 1 times x minus 4. So if we were to graph that from the center, which I made my center green, I'm going to go up 4 over 1, down 4 over 1. There's one asymptote. And same thing, other direction. So this
These are gonna be fairly wide.
hyperbola opens much wider. Goes closer to those asymptotes.